Hello and welcome to this session on architectural shift in 5G. My name is Nitin and I'm joined today by my colleague Aditya Kaul. We are both solution architects in the Juniper Networks APAC team. And today we want to discuss with you about how 5G is impacting the operator networks and what architectural shifts it's causing inside the networks. So let's get right into it. So the 5G era has already begun. We've got about 158 different operators who've launched services on 5G. 100 million plus subscribers that are already using 5G services, and about $1 trillion of capex that has been allocated specifically for 5G investments between 2018 to 2025. If you look at from the perspective of the segments that 5G is going to impact, it includes enterprise, government, as well as consumer services. But the key question that comes up quite often is that what is that killer application for 5G? Unfortunately, that's a question that's difficult to answer. But if we look at some of the high-level analysis and trends, it's very clear that while we don't know what that killer application is going to be, we definitely know that the killer segment is going to be enterprise. There's about $3.4 trillion that's expected to be invested by the enterprise in this 5G technology. And this is just the 5G mobile technology. Along with that, there's going to be cloud and AI and all the other investments that will go along with this. So the enterprise is the segment that is going to be the largest investor in 5G, as well as is going to be the largest benefit reaper out of this technology. If you look at some of these industries, such as industrial automation is expected to have 18% of this $3.4 trillion share of the investment. And this is going to impact everything from any machines or the smallest chip, which is going to be either tracked or controlled through wireless technology. Similarly, if you look at other areas like healthcare or robotics, there's going to be a huge impact that 5G is going to have in these domains. AR, VR, for example, is going to impact the retail segment in a very significant way of how we will interact and shop in the new age retail malls. If you look at the consumer segment, the cloud gaming is expected to be one of the biggest revenue spinners for 5G. And the whole gaming ecosystem is expected to change from the handheld games towards cloud gaming that is delivered through the edge using 5G. Similarly, AR, VR is approximately 20% of the total traffic inside the Korea network where they've launched 5G. And this is very exciting in terms of the new technologies that 5G is enabling. FWA is one of the first applications that we will see on the residential side for 5G. From a government perspective, the focus is going to be on energies and utilities because that's where a lot of the transformations are expected to happen. And also in segments like smart cities and automotive, where there's going to be a lot of public-private partnership in terms of how we deliver these services. While we don't know what that killer application is going to be, we definitely know that 5G is going to set that base on top of which we will be able to, first of all, launch these applications that we already know, but also be prepared for those unknown applications that are expected to come in the future. So with all of this said, one of the questions that again comes up is that what is it about 5G that makes it different? Is it just about the speeds or is there something more to it? So let's look at two of the components of 5G that are critical to create this differentiation for 5G, and that helps it to enable all of these different applications that we spoke about to really unlock its potential. The first of these is network slicing. Traditionally, we've offered networks which are one size fits all, and they've not really been dedicated for service differentiation inside for different kind of use cases. With network slicing, we have the opportunity to build dedicated end-to-end virtual networks with prescribed SLAs for all the different services. So whether you have healthcare or industrial automation or a V2X application, you can allocate dedicated slices with prescribed SLAs for those, which will offer the real differentiation that is required for these services. If you look at some of the studies that have happened, operators are looking at network slicing as one of the key ways to monetize 5G. And this report from Ericsson is kind of a testament to that fact. What Ericsson is predicting is that 34% of the revenue growth that the service providers are going to have till 2026 is going to come from non-best effort slices. So only once service operators start to launch network slices, which are dedicated for services, that's when they will see this uptake in revenue. And 34% is a huge potential for growth for service providers. The other key technology that's going to be a differentiator in 5G is Open RAN. So we all know that one of the key motivations for Open RAN is to reduce the vendor lock-in that exists today inside the RAN domain. But one of the other key things that Open RAN, the opportunity to launch new services and monetization options. The adoption for ORAN is expected to grow almost tenfold in the next 6 years. We've already started to see some initial deployments happen in operators, but currently a lot of the operators are in trial phases to look at how Open RAN applies to their technologies. If you look at the use cases, they include traffic steering, RAN slice optimization, massive MIMO, RAN sharing, energy efficiency, and a lot of these different use cases. Now, another key component within Open RAN is that how do you monetize services using Open RAN? Open RAN is great because it helps you unlock innovation. It helps you unlock, the vendor lock-in so that newer players can come in. But how does it enable monetization? So for monetization to happen with Open RAN, we need a RIC, a RAN Intelligent Controller. And this RAN Intelligent Controller basically provides the operators the levers that they need to be able to fine-tune the RAN network based on the requirements that they have for the specific services or the network types, etc. If you look at some of the recent trials that have happened, Vodafone, for example, just concluded a trial where they used the RAN Intelligent Controller to increase their cell site capacity by 2 times in one of their massive MIMO use cases. Similarly, KDDI last year demonstrated how the RIC is going to become the control point for them for network slicing within the RAN domain. So with that said, let's now look at what is the impact that these new technologies are having on the service provider networks, on the operator networks, and how we expect this to evolve. So definitely with all of these changes that are happening, there is a shift in the architecture that's happening in each of the domains inside the operators. So including the RAN, the transport, as well as the core. If you look at the RAN, we spoke about the Open RAN that is, enabling new interfaces to be formed. The cell side is becoming significantly simpler because we're reducing some of the active components from the cell side, and the components like the control unit and the data unit are getting distributed much deeper inside the network. And this also has an impact on how the networks get designed front haul and for mid haul in terms of the requirements for the network in terms of timing, latency, etc. And last but not the least, as we said, for the RAN, a key portion is how the architecture is going to change to adopt the RAN Intelligent Controller so that you can have enhanced intelligence inside the RAN. From a transport perspective, the focus is all around reducing the protocol layers to make the transport simpler and to virtualize and disaggregate wherever it makes sense. The last but not the least, from a transport perspective, the key trend that we're going to see is a shift of the traffic and service delivery from the edge or traditionally from the core towards the metro and to the cloud. So the metro is going to become a melting pot of where all of this is going to come together in terms of the integration to the cloud, the network slicing, and all of those different pieces. And last but not the least is the core, where the architecture is definitely changing towards a more microservice-based, service-based architecture, and the distribution of the core into multiple points inside the network using the distributed UDF or the MEC. So with that said, in the rest of the section, we are going to focus more around the RAN and the transport pieces. And with that, let's dive in a little bit deeper into what does it take to make all of this happen end to end. So if you look at this from a network slicing orchestration perspective, because that we see is going to be the key driver for the architecture change as well as for how services get delivered. So let us look at this from the perspective of network slice orchestration. So at the highest level, we see that just below the OSS and VSS, we have the service orchestration layer. And that service orchestrator is then talking to the specific domain controllers in each of the domains. So the RAN domain controller orchestrator for the RAN, the transport domain orchestrator for the transport, and similarly the core domain orchestrator for the core. Now let's peel the onion a little bit more to look at how this looks like from a network slicing perspective. So we can see here that the service orchestrator has a slice management function, and then that slice management function is also translated into each of the domains. So each of the respective domains have their slice subnet management functions, plus they have something that's a controller for that specific domain. So, for example, in the RAN domain, you can see that's the non-real-time RIC. In the transport domain, that's the WAN SDN controller. And then in the core domain, we will have the NFVO layer. So each of these domains are going to be responsible for the orchestration and for the slice management within their own domains. And they will be talking to the service orchestrator that is responsible for stitching all of this end to end. So let's now delve a little more deeper into the RAN domain. And then from there on, we will move on towards the transport. So as you can see, the RAN domain, if we blow this out, we see that it has a few key components. The first is the service management and orchestration, which is the SMO. And the SMO has a few components like the management and orchestration, the OAM, the RAN slice management, as well as the non-real-time RIC. And then we have the O-Cloud, which is the layer that provides the containerization and virtualization for all the applications that are going to sit on top. So let's now look at how all of this comes into play and how this whole slicing orchestration works from a RAN perspective. So the first thing is from the management and orchestration perspective, we talk to the O-Cloud, and the O-Cloud brings up the respective control plane or the user plane functions like the CU control plane as well as the near real-time RIC. Now, as you can see, the RIC has two components, the non-real-time RIC that is under the SMO and the near real-time RIC that is sitting next to the CU control plane. And each of them have their own set of apps, and we will discuss this in a little more detail in the next slide. But the key thing is that the management and orchestration informs the O-Cloud to bring up the control plane as well as the near real-time RIC. In the next phase, the operations and maintenance talks to these components to make sure they've been brought up appropriately based on the requirements. And then collectively with the RAN slice management, the user plane is set up based on the different network slices. So this includes the CU user plane as well as the DU functions. Now, as you can see, these functions can be distributed into multiple clouds, regional cloud, edge cloud, cell site, and this would depend upon the type of deployment that operators have. But overall, the model is flexible enough to support these kind of deployments. Now, once we've done this, we need to tie this back to the transport domain and how does these slices translate into what's happening in the transport domain. So for that purpose, the RAN domain orchestrator or this SMO talks to the transport domain orchestrator to orchestrate the respective tunnels that are required in the transport to make all of these slices happen. And Aditya will talk more about how each of these tunnels come into play, how are they formed, and then how do they talk. They help these clouds to talk to each other, the clouds between the cell site and the edge cloud and the regional cloud. So let's look at it a bit deeper into this non-real-time RIC and the near real-time RIC. The non-real-time RIC, as we mentioned, it resides inside the SMO and it hosts the R apps. So the job of the non-real-time RIC is to provide policy-based guidance. It tells the near real-time RIC what it needs to do. And the near real-time RIC sits very close to the edge cloud. It resides inside the edge cloud, very close to the CU control planes, and it hosts the X apps. And this is where the what gets translated into the how. So the near real-time RIC talks to the CUs and the DUs and translates the policy guidance that it receives from the non-real-time RIC into the actual commands to the CU and to DU to make the actual functions happen. So in the end, when we want to realize the use cases for the RAN, which includes the slice orchestration or the massive MIMO or the other use cases like RAN sharing, then this is the non-real-time RIC and the near real-time RIC have a very important role to play to make these happen. And the key thing here is that both of these support the hosting of third-party apps, the R apps and the X apps, which is where the most of the innovation is expected to happen. So from a Juniper perspective, Juniper has acquired a company called Nexia, and we will be building both this non-real-time as well as the non-real-time and the near real-time RIC, as well as the SMO functions. So that is how Juniper is contributing from an ORAN perspective in this domain. So now we've discussed how things look like from a RAN perspective. Aditya, so how do you think this translates in terms of requirements for the transport domain? So is the transport domain, the way we have it today, is that good enough, or does that require some kind of a change?
Yeah, thanks, Nitin. So let's start with the base IP transport infrastructure. there is a significant shift required in terms of the transport architecture to address the 5G requirements. And so what are those requirements? First, 5G services and cell densification. Now, this brings a massive bandwidth and scale increase, majorly in the metro or XHAL networks. This also brings a massive explosion of end user IT devices, whether we have these devices as enterprise CPs, IoT devices, or consumers. Having said that, timing has become much more stricter with 5G, and low latency is now a key requirement. Another requirement which we see for this architecture shift is around service differentiation and application-aware routing. Now, this is a basic requirement when we talk about network slicing. Meanwhile, we also see a need for centralized automation control and distributed performance, which requires a hybrid architecture. How do we address these requirements? We need an architecture which is scalable, stateless, and most important, it should be simple to operate. Having said that, segment routing, if you see segment routing as a foundation for the IP transport architecture, it's a key enabler that can reduce our protocol stack by up to 70%, which reduces the state and the scale requirements. It is also inherently programmable, which kind of provides a centralized automation control. Now, within segment routing, there are two approaches with similar benefits to achieve the end objectives of 5G. SR-MPLS, which is segment routing for MPLS. Now, this is best suited for existing MPLS networks as it brings the least disruption and also mitigates risk during migration to SR or the evolution to SR. Now, within SR-MPLS, we also have tools to integrate with nodes and networks, which may not be capable enough to deliver SR day zero, or which would require a certain software upgrade to deliver SR. Now, the other flavor of segment routing, which we call as SRv6, which essentially is segment routing for IPv6, this is best suited for greenfield networks as it brings the massive scale of IPv6 and also interesting capability to embed the intent within the packet. Now, from services evolution perspective, we see a shift more towards EVPN, which provides a unified services architecture for both layer 3 and layer 2 VPNs while being transport agnostic, which means it can run over plain IP, any flavor of MPLS or SRv6. So this is the basic IP transport infrastructure requirements which we see happening with the advent of 5G. Next slide, Nitin. All right. So what are the key end-to-end network slicing requirements? So within the IP transport world, we have been traditionally delivering network slices as in layer 3 VPNs or layer 2 VPNs. However, with 5G, we see new requirements, which require networks to adhere to stringent SLAs, and also very important, a need to map similar intent within individual domains like RAN, metro, core. So these are essentially holistic requirements. But what about the key network slicing requirements? First and foremost, traffic isolation. Now we need to maintain traffic separation for different slices or customers, and also a mechanism to provide security and segmentation. Another requirement, key requirement, is topology-aware slice. Now, what do we mean by topology-aware slice? It essentially means a slice, for example, a low latency slice, which requires a latency path between the consumer and the application, and not necessarily a shortest path to reach a destination as defined by IGP, which essentially might not be the lowest latency path. And one of the most important aspects or requirement from network slicing perspective is the end-to-end orchestration mechanism. Now, this is the key to maintain the intent which resonates with consistent intent within each domain. This also unifies the mechanism to deliver or provision the intent across different domains like the RAN, the metro, the core, and finally, assurance and guaranteed availability of network resources. Now, this is a key aspect which is requested by the slice. So these are essentially the key end-to-end network slicing requirements. This is a public demonstration of Juniper's slicing solution, and there is a URL there. This provides you a view of how to create and maintain transport network slices using Juniper's North Star controller, which essentially is one of the most important aspects when we talk about automation and centralized control. You could visit the website for the demo and the technical details. So now we have covered from a transport aspects of the 5G and also the requirements in terms of the network slicing perspective. So Nitin, what's your view on the end-to-end slicing mechanism and how do we stitch these domains essentially?
Yeah, thanks, Aditya. So as we discussed, we've looked at how the RAN and the RIC inside the RAN is going to take the responsibility of doing the slices inside the network, inside the RAN domain. We've looked at how the transport is going to look at taking that intent and translating that into controller requirements from a transport perspective. The key here is that how do we stitch all of these together? Firstly, from a multi-domain perspective, so that whether the intent is from the RAN or the transport or the core, we can ensure that that intent is delivered seamlessly across the entire network. And so that is the first component, which is where the service orchestration piece comes in. But the other thing is that we also, in addition to being multi-tenant, we also want this to be multi-domain. We also want it to be multi-tenant and multi-cloud. So what that means is that in terms of offering these services, this could also be offered as a tenant-based service wherein an enterprise or an MVNO might buy a slice or a hierarchy of slices within an operator network, and they may want to run it like that. So you want to be able to create network slicing, not just for your own operator requirements, but to be able to create it for hosting other operators or other enterprise services on top of that as well. The other thing is that we also need to be able to extend this not just into distributed clouds within the operator network, but also into the public cloud, because we expect that a lot of these services that are not latency sensitive will eventually move to the public cloud and be hosted out of there. So we need to be able to ensure that we can do all of this stuff and do it at scale. So that is kind of like the high level message. So with that, let's wrap this up with the three key messages that we discussed for today on how the architecture for the operator networks is changing because of 5G. And there are three key architecture shifts that we're seeing. The first one is Open RAN, which is making the network simpler from a cell side perspective. It is making the RAN more intelligent by using things like the RAN intelligent controller. The second piece is the transport, where we are significantly simplifying transport by reducing up to 70% of the overheads. We are making it more application aware, and we are tightly integrating this with the RAN and the core domains to make this an end-to-end solution. And last but not the least is network slicing, which has to be multi-domain, multi-tenant, and has to be executed at scale. With that, we thank you for your time, and we hope you found this session useful, and we'll probably see you in the next one. Thank you.
Thank you very much.